Hello and welcome to the TechBrain channel. In this video, we discuss sharding in MongoDB. Sharding is a technique used to scale horizontally in MongoDB. Mlaunch is part of an open source set of tools referred to as Mtools. It allows you to spin up complex MongoDB environments on your local machine. And this is what I'll be using today. So we look at horizontal scaling in MongoDB and we end up setting a three-sharded replica set. So let's dive in. I have put a link below, so if you'd like to explore mlaunch, feel free to do that. You will need to set up some Python dependencies, but apart from that, once you get it going, you can do quite a lot. So I'm mostly focusing just on the sharding aspect. It is a wide library of different tools that you can use to do things like visualize logs in MongoDB and also filter your logs. But I'll be focusing just on the sharding side of things. So let me go to the website. So this is the website. So as you can see here, with mlaunch, I'm able to spin up and monitor MongoDB environments from my local machine. Uh, because normally, if you're trying to set up a sharded cluster, you will require a lot of hardware. Doing it this way helps you to experiment and learn all the ins and outs of sharding. So the commands to set up sharding are what we see over here. So there are two ways I can actually launch a sharded cluster. Either I launch what's referred to as an unnamed shard, in which case the names of the shards are generated for me. Alternatively, I can actually launch named shards. So this second command here, I'll have three sharded clusters. I'll go for this approach, and I have already run that command. So we can see the output of that command. So this is me running the command which said mlaunch replica set sharded tic-tac-toe. I do have a MongoD running on this machine, so that's one of the prerequisites. And it's able to spin up my MongoDs running across these ports. So how many do I have in total? So that's 3 there, that's 6, 9, and 10. Let's see that again. Yeah, looks like we've got 10. So we've got a config server running on that port. And if I'd like to connect my sharded cluster, I'll be connecting to a Mongoose. So let me do that. So I'll go Mongoose. And I'm connecting directly to a sharded cluster. So if I do sh.status, I can see the configuration of my sharded cluster. So I have 3 shards. The first shard, TAC, with 3 nodes running across those ports, and likewise, second shard, third shard, and there's an active Mongoose that I connected to. The balancer is currently running. As you'll know, the balancer is a process whose job it is to balance data across my shards within tolerances that MongoDB defines. There is a config server, so the config server has all my metadata specifying where key ranges live. So at the moment we're reading this as saying the min key to the max key is currently on the shard TAC, as we can see there. So the scenario to this demo is that I have 3.5 million product reviews. Rather than have these in one collection, I'd like to partition them across 3 shards. So remember that each shard is a replica set with a primary and 2 secondaries. So we'll start with an empty sharded cluster. We'll load the data. We'll have made the choice around the shard key that we need. So there are commands that I can run from the shell to actually enable the sharding. One of the other things we do is try to compare a shard key against one version or one shard key candidate against the other to work out which is the better shard key. It is essential when partitioning my data that I choose the most effective shard key. So all the care that I take when selecting perhaps the keys for a compound index, I must exert similar care here. Shard key should be non-monotonically increasing, otherwise I'll end up with hot shards. Also, my shard key should take into account selectivity and cardinality. So these are quite important things. I must also add that it'll be useful for me to look at the distribution of my candidate shard key across my documents. What is the frequency of occurrence? That is a factor as well in the selection of an effective shard key. So I'll be doing all of that. So let me go back to my terminal. And what I'll do here is get to load some data. Well, I am working on a Windows machine. It's a long story as to why I'm doing that, but I do have the tools to be able to curl into a data source. This is my data source here, and I'm going to be downloading. So yeah, permissions error. Make sure that I'm doing that as an admin. So I will go to CMD, fire this up, make sure I have gone in as admin, and then rerun that command. So I'll move this over here, and we'll say something like that, and we'll say cd data, and I will attempt to download. Okay, that looks a little bit more promising. So with my data there, and after the data download, after the data download, I need to import that into my empty sharded cluster. Okay, so the data has been downloaded. A few things I need to do include unzipping that as well as importing it into the relevant collection. So let me do that. So I'll go to my other screen and I'll unzip it from there. So just extract findfoods.json. So as pointed out in the slide, there's about 3.5 million small documents in there. Okay, so that's done. The next point is to import the data. So to import the data, I can run a Mongo import. Refresh. So just to give you an idea, this is what my document looks like. So this is the entire findfoods.json. So just under 2 gig, just over 2 gig. There's over 2 gigs worth of data in there. Okay, so now let's import that data into a collection. I will now proceed to import the data. So just to remind myself, I do have something running on port 27017. I'll go to the output of my sh.status to find out which shard I can load the data into. Let me go here. So I do have this shard here. So I could actually load it into any of these here. So I'll do that. We begin our data import. As you can see, I'm importing my data, find foods. So these are all the product reviews. So this takes about 5 minutes or so. So we'll come back to that when it's done. So in the meantime, Just to remind ourselves, we haven't sharded the data, it's just being loaded into what you might refer to as perhaps a staging area before we partition it. So let's wait for it to be imported. Our data load is now complete, as we can see here. We've imported 3.5 million documents. So let's explore the resulting collection. If I check what collection I now have, I've got a fine foods collection, and we'll just query for a single document. So this is what a typical document looks like. We have a product ID, user ID, and there is a score, time. Unfortunately for us, the time is not a Boolean date time. We can't do much with that until perhaps we perform some sort of conversion. So that's one of the things that you need to look at your source data. Is it of the right type? The score, we can't do much with the score, but presumably a query into this collection would be looking for the review for a given product. So we've got our product ID, so we can query by product ID if we need to do that. So there are two possibilities. Either we have a query that uses a product ID or user ID. If that's the case, what is the best compound index? So there's a quick test we can perform here just to see what the distribution of the product IDs is versus the user ID. So a rough measure of the cardinality. So the way I'll do that is by running a query with distinct. So if you haven't used distinct before, you can access the documentation for distinct, and it says you pass me a field, a query, and some options. You can go online as well. That's the URL to um, documentation. So what I'll do is just run distinct with a field I'd like to um, check on, and the field is going to be product ID. I think that's what we had. I'll just check that again. We had product ID as well as user ID. So how many distinct product IDs do I have? So say product ID. So that should give me back an array of distinct product IDs, and of that I can get the length of the array. As you can see, this is not the fastest of queries. It's having to scan through all those documents. So I could do something like this. Since it's an array, I could simply get the length of that array. So these are all the distinct product IDs. We'll do the same thing for the user ID. As we can see, we have 74,258 distinct product IDs. How many distinct user IDs do I have? So go and do that for user ID as well. We have 256,059 distinct user IDs based on that command there. What we know about our system or the platform that we're building or the app that we're building is that a query into this collection or into this data set might look something along these lines. We have a product ID as the on this collection might look something like what I've got here. So if I look at F, so we're querying by product ID, user ID. So if we say db dot find foods and find where we've got that as the filter. So currently this will be a collection scan. We don't have any indexes in place. Okay, we get the result back. It's very, very slow. And this is one of the challenges that we have with this collection. Quite rightly, we can create an index, but it ends up being a fairly large index on that one collection. Remember that we're looking to scale horizontally here. So what we'll do to enable sharding is to say something like sh dot enable sharding. So this command here requires us to pass the database and the primary shard. So what is our primary shard? I mean, it's optional. We could do that. The other way to do this is to say sh dot shard collection. So we've got that as the command that will be running. We want to shard a specific collection, so namespace is going to be the fully qualified name of the collection, followed by our shard key and any other options we might have. So let me set these up. Namespace. So we'll say that namespace is equal to find, I think it's test dot find foods. And the key that we're using is going to be a document. So we've got the product ID followed by the user ID. If we already have data in our collection, we must make sure that there is an index that uses that combination of keys. Let me try to shard my collection now. So I'll say sh.shard collection. This command will definitely fail. And the reason it will fail is that we haven't created an index that uses this shard key combination or that combination of fields. We'll say key, and we can see right away that we get a Mongo server error, which is quite clear. Create an index that starts with proposed shard key before sharding the collection. Let's do that. So we'll go here and say db.findFoods and create an index. And for the index, I'll just pass the key that I've defined there. Okay. So the choice of this shard key is based on the queries that we'll see coming through the system. So it's got nothing to do with the metrics that I was able to pull out. It showed us that user ID is higher cardinality compared to product ID. Yeah, there'll be more users reviewing these products than there are number of products, distinct products. So anyway, we're creating an index to meet this requirement that triggered the error. Okay, so we do have an index in place. So I'll reattempt to shard the collection. So it says, yep, happy with that, I'm sharding your collection. We can then explore whether our shard key ranges have started migrating. So if I say status, we can see whether the balancer has performed any balancing rounds. So let's have a look here. We can see that no migrations yet. Let me run it again. Okay, we can see some migrations. So there's one migration that's succeeded. And the migrations will continue. So I'll come back in a bit and check the status again to see how much of this data has been migrated. Also of interest will be queries. How do queries actually run against this collection? Remember that I had a query earlier where I had this filter. Let me see what my find looks like with execution stats. So explain, and I'll pass in execution stats. So here's what we see. In the explain plan, we're hitting a single shard. We're not doing any broadcast, and that's because our query contains a shard key. So we hit only one shard here, single shard. What happens if our query doesn't contain a shard key or the prefix of the shard key, which in our case is the product ID? So I'll make this change. So do that. And what we notice is execution stats taking a lot longer than before. And what should be interesting also are the stages that this query goes through. So I'm querying for user ID. I'm missing the prefix to that shard key, which is the vital piece of the jigsaw. And we can see that I've had to hit the shard tick, tack, and toe, and the results were merged. I only got 8 results returned. But look at the amount of processing that had to happen. A call scan, where we're looking for that specific value. Another call scan looking for that specific value. So 2 found here, 6 found here, and nothing found there. So this is a scatter gather. The results were merged. Very inefficient and not a great use of my server resources. So my queries in a sharded cluster should always reference the shard key. Otherwise, you'll have a scatter gather, a broadcast, and that's quite inefficient. So anyway, looks like we can probably go back and check the status of the shard key distribution. So let's see what that distribution looks like. So there have been more balancing rounds happening. So there are 5 more. I think last time when we checked this, we'd only had 6 balancing rounds. So we only had 5 balancing rounds, so we now have 6. And this is the distribution. So the balancer is having to do all this balancing, making sure that there's another round that's just completed. So the balancer is having to do this to make sure that there is a uniform distribution of data within predefined tolerances. And this is what the chunks look like. So on shard tack, we have 3 chunks. And obviously here we've got 4 chunks, 1 chunk there. So the system will continue running. So there's another balancing round. Okay. We have been able to shard our collection. We started off with an empty sharded cluster. So sometimes you don't get that luxury of starting off with an empty sharded cluster. But if you do have the option of starting off with an empty sharded cluster, you could actually do this migration manually instead of letting the balancer do that. Okay, so what do we explore next? One of the things we wanted to examine was just how effective this shard key was. How can we measure the effectiveness of a shard key? One of the improvements or enhancements that is now available in MongoDB is the ability for us to measure the effectiveness of a shard key. Let's see how we do that. We are now going to measure just how effective our shard key choice is. So what I've got here are some candidate shard keys that I could have used, additional candidate shard keys. So we used the product ID since the rationale for this was that would be more likely to query for a product review rather than query for a user that left a product review. So we're more interested in finding out the reviews for a given product with an option to query for a user. So just how effective is this shard key? We do have a command that supports this kind of measure or this kind of assessment. So it's the DB admin command, analyze shard key. That's my namespace, and that's the shard key I'm looking to analyze. Let's see what this reports back. So while this is running, we need to remind ourselves of what the characteristics of a good shard key are. So a good shard key should be non-monotonically increasing. It should also be high cardinality. I think we've got no such problems with our shard key selection here. Also, select a shard key that doesn't result in jumbo chunks or jumbo chunks. So these are chunks that become indivisible and cause performance issues in your sharded cluster. So let's await the results of this assessment. So on my machine, this command took a while to run. So I was waiting probably about 10 minutes for it to complete the static analysis. There was no other load while I was doing that. Apart from the balancer running, I wasn't actually doing any reads or writes. So the results of this assessment of the current shard key are as follows. I get an array here that tells me what the most common values are, but also there is an important metric here, average document size, 634 bytes. So it tells me that for this key combination, there's a frequency of 22. So that doesn't look too bad. Remember that the default chunk size is 128 megabytes. So 634 by that, let's do the math. So that's the size in megabytes. So 0.013 megabytes, sharing that shard key range on average. So we're not really bothered by there being jumbo chunks in this case. The other measure we get is the monotonicity. So we've got a record correlation coefficient, which is in the negatives. So this is really telling us that the record ID, which is something that you'll see when you query your data, there is very little correlation between this combination of fields and the record ID. And we can see the read distribution and the write distribution. We had nothing happening at the time, so we're going to get zeros for that. So the important measure is this one. The smaller the better. If this is 1, then your choice of shard key is bad. This should be as far away from 1 as possible, as small as possible. Also, if you do the simple math like you saw, I've got 22 documents sharing that shard key. Average size of a document is that, what's the total size there? 0.013 megabytes is, I think, what we found there. So all in all, we've got a great choice for shard key. We just need to make sure that this shard key combination is present in our queries. More importantly, the prefix is present in our queries. So that is really just a foray into sharding in MongoDB. As you can see with sharding, I can have unlimited scaling. Okay, so that brings us to the end of this demo. Remember to like and subscribe. If there are any topics that you'd like us to cover in the next set of videos, please drop a comment. So yeah, like and subscribe. Until next time, see you. Bye now.